doing well, and be happy and stay inspired. We are just directly going to this first chapter, reflection of light at curved surfaces. I think from your 7th class and 9th class, 8th class, we learned some basics regarding this reflection of the light, some terms regarding concave, convex, plane mirror and all those things. So this chapter is basic, explain the concept regarding how the image is forming in the case of a curved surfaces. That means the concave and convex surface. First of all, I am just reminding you that in your 10th class physics, this first chapter and fourth chapter and the fifth chapter, these three are interconnected. First chapter is basically related to these mirrors, and fourth chapter is related to lenses, and the fifth chapter is the application of this both the first and fourth chapter. So what I am planning is this first chapter I divided into three parts. Today we will deal about the basic terms regarding this spherical mirrors. I hope you know what is this spherical mirrors and how we will find out the basic terms and all those things. First, for an example, for your common understanding, I will just show. Suppose you all knows what is this plane mirror. Okay, suppose if I am taking like this one surface, just for a demo I am keeping like this. So one surface will be reflecting, another will be non-reflecting surfaces. So this is a plane mirror, just for an example. This is a plane mirror, and how we will draw a normal to this plane mirror. What is a normal? Okay, normal means it is the perpendicular to the surface. So suppose if I am keeping anything that is perpendicular to this particular plane, okay, that is known as normal. Okay, now we will discuss about this concave mirror. Okay, so basically concave mirror means that reflecting surface will be curved inside. Okay, so in this case all the normal, okay, if you are looking from the reflecting side, we will feel that all these normals are coming towards a point. Okay, so it is converging towards a point. So this concave mirror is also known as converging mirror, and convex mirror, since we are feeling that it is coming from a point, it is known as diverging from a point, it is known as diverging mirror. Hope you understand what is basically concave and convex surfaces. Now terms related to these spherical mirrors. First of all, we will deal what is center of curvature. Okay, suppose here for this plane I am keeping four normals. Okay, 1, 2, 3, 4, and this is the case of a plane mirror. Okay, now suppose if I am making it into a curved surfaces, you can observe this one. These four normals are coming towards a point. Okay, so this point is known as the center of curvature. So this is the basic thing. Suppose if I am taking a plane mirror or plane surface, and if I am curved towards the inside, okay, so this point is known as center of curvature. Okay, now we already learned what is center of curvature. Center of curvature is, suppose if you are drawing the normal, or where all the normals are coming and meeting at a point, this point is known as center of curvature, and we are denoting the letter C. We are going to deal what is principal axis. Principal axis means it is a line. Okay, it is a line that going through the center of curvature of the mirror. We already learned what is center of curvature. Okay, it is a line that is going through the center of curvature of the mirror, that is exactly perpendicular to the surface of the mirror. So suppose it is a center of curvature and this is the surface of the mirror. So if it is going exactly the perpendicular to the surface of the mirror, so this line is known as principal axis. Next day, pole. Okay, pole means it is a point where the principal axis touches the surface of the mirror. Now we already learned what is principal axis. This is principal axis. Okay, this line that is starting or passing through the center of curvature and the surface of the mirror. So where it is touching the surface of the mirror, that point is known as P. Okay, hope you understood what is pole. Pole means it is a point where the principal axis touches the surface of the mirror. Next term is focus. Focus is a point on the principal axis of the spherical mirror at which the light ray which are parallel to the principal axis. So suppose a light ray that is coming parallel to the principal axis actually converges or appear to diverge after reflection. Simple way, if you are explaining this one means, suppose if a light beam that is coming parallel to the principal axis and after reflection where it touching on the principal axis, that point is known as focus. Suppose if a light beam that is traveling parallel to the principal axis after reflection where it touching on the principal axis, that point is known as focus point. So this focus point also we can make into two cases. Suppose if you are taking a concave mirror, suppose this is the case of a concave mirror, so in this case we can observe that we will feel that it is converging towards a point. Suppose if I am taking another beam of light and after reflection it will converge towards a point. So in the case of a concave lens it is converging. And suppose if you are taking the convex mirror, we will feel that it is coming from a point. Another beam of light. So for the case of a convex mirror, we will feel that after reflection it is diverging from a point. So this focus, for the case of a concave mirror this is the focus, and for the case of a convex mirror this is the focus. Last term is focal length. Focal length is simply the distance between the focus and the pole. So focal length is the distance between from focus to pole. How much distance is there? That is known as focal length. Okay, so by this I am just concluding today's session. Hope you understood the things which I explained, and at the end of this video I will provide some questions. Try to do it and get ready for the next class. Be happy, stay inspired. Goodbye.